So I figured we'd do, since we are doing a little plasma cutting on the paint panels, is I show you another way to do it on a CNC plasma cutter. And I'll show you how to do a quick little design and how the machine works. So I thought I'd just do a quick one here of the panel. So what this is a computer to control the plasma table. And what it has is a couple of designing programs, one for doing like logos and stuff, and the other just for doing like parts. Then a program for converting everything into a G code, a code that operates the table, and then the actual table controls what the table is doing as it's cutting and everything. So I'm going to come in here to QCAD, and CAD is computer-assisted drafting, computer-aided drawing program. So what we're going to do, we're going to come in here. There's our work area. I'm just going to zoom in a little bit. I'm going to come up here. I'm going to name it. All right, so I'm going to save as, even though I haven't done anything, I'm going to save it as paint panel. That way, as you're working through it, you can just keep saving it so you don't lose any of your drawings. We're going to overwrite that one. All right. So what I'm going to do is I'm going to make just a rectangle first, and our paint panels are 20 by 24. So what I'm going to do is I'm not going to show you how all the programs work. Just going to do it in front of you so you can kind of see how it works. So I'm going to do a horizontal line right here. All right. And what I'm going to do is, you can see up here, you can put whatever length you want. And so it's already 20, but 20 inches horizontal. And I'm going to come down here. You can drop it anywhere, but I kind of go around that center reference mark right there. I'm going to come over here and I'm going to do a vertical line, and the vertical is 24, 20 by 24. I'm going to come over here and I'm going to drop it on the end of the line I first put in there. And then I'm going to come back and I'm going to put another horizontal line that is 20 just to fill out our box. Boom, and we drop it. And there is our rectangle, 20 by 24. I can always come in and double check my measurements if I needed to. This one here is 1 foot 8 inch, 20 inches. The other way is 2 feet, which is 24 inches, so we're good. What I want to do next is I want to put my holes in there, okay, and I need to figure out where I can't just pop them anywhere. I want to make them fairly accurate. So what I'm going to do is I'm going to add a couple layers, and I'll show you why it's important later. The holes will be on a separate layer than the outer perimeter. So I'm going to come over here. I'm going to come in. I'm going to call this one holes. Okay. I'm going to say okay. So we got our holes layer. I'm going to do another one that says guide. So this will be our guide layer. So we're going to make that a different color. And we're going to say okay. What I want to do, since we've been using these discs for our corners, to make our round corners, this is a 3-inch disc. Right? So the outer radius will be 3 inch right there. Right? So what I want to do is I want to find the center. So the center of 3 inches, 1.5 inches. Right? That's where our hole is going to be. Okay. So I want to come in and I'm going to say I'm on my guide layer. I'm going to modify. I'm going to do an offset, and so half of 3 inches, 1.5. So I already have 1.5 up here in my distance. What I'm going to do is I'm just going to just bring it up to the edge that you want to add a distance to. And what we have now is our intersections there where we can drop our holes. So what I'm going to do now is come into the holes layer. I'm going to come over here to make a circle. I'm going to drop this in there. So what I had was a 1/4 inch hole. I made it just a little bit bigger. The machine doesn't like to cut really small holes, so I made it up to 0.300. This all works in decimals. So 1/4 inch would be 2.250. So I wanted to go just a little bit bigger, so added a little bit, 50 thousandths, and came up to 300 thousandths. What I'm going to do then is I'm going to come over here and I'm going to drop it on the intersection. We're going to get out of that. Now we can get rid of our guide, and you can see that we have our outer perimeter and our holes, and those are both on different layers. So I can hide the holes, and I can hide the outer perimeter. Last thing I want to do is I want to round off these corners. I'm going to come up here to modify, and I'm going to round them off. And I've already got punched in there. It's a 3-inch radius. So 3 divided by 2. And what we do is click the 2, sides we want to round off. And you can see it'll go to either side depending on what side of the line you're on. I want to make sure you're on the right side. Get out of that. We were on the wrong layer. So I'm going to back out. So let's get out of that. Come back up to the correct layer. And then I'm going to do the same thing. It's all a learning process. I'm still learning this. Click, click. All right. Now, if I get out of there, our outer and our holes. Okay. We're good. We're going to save that. So Control S or come up here and save. All right. So this is our paint panel. All right. So next thing I want to do, I can get out of here. I'm going to come up to my next program, which is called SheetCam. This is what gives the drawing some sort of a code to navigate the table. All right. So I'm going to open up SheetCam. All right. So here's our SheetCam. This red, dark red, represents the plasma table. So the plasma table is 4 foot by 4 foot. So this is representing 4 foot by 4 foot. Right? So what I'm going to do is I'm going to bring a drawing in. So import drawing. So we're on paint panel. I'm going to open that. And there's our panel. Okay? So back out a little bit so you can see it in relation to the 4 by 4. And it'll do three-dimensional kind of stuff too. So I'm going to get rid of the guidelines, hide those, so we're just left with the actual part. And I'm going to do it in order. So we always do our holes first before the outside, otherwise the part will shift. And if you're doing like precision part, your holes will be shifted. You don't want to get those off. So I'm going to click on holes, and I'm going to come up here and do a new operation. This is what controls that layer. So we're going to come up here. So for holes, we're going to do an inside offset. We're going to do the holes, and we're going to pick our tool. So the thinnest we've got on the steel is 16 gauge. We're probably doing 22 gauge out there. So this will be pretty close. I mean, it'll be fine. So what I want to do is I want to check the parameters of that. So what this does, you control the voltage and the speed and everything of the torch. So this is going a little bit quick for me. So 249 inches per minute. I want to cut that down. I'm just going to cut it in half. 125. Everything else looks all right. Our voltage, we'll try that. Say okay. I'm going to get rid of the lead in and lead out. That way it fits inside the hole better. 125, so that's fine. Okay, everything looks fine. Next thing we're going to do is the outside, which is layer 0. Same deal. So I want to come in here, and this is on the outside now. I'm going to do the 0 layer. All that should be the same, so I want to double check to make sure it's carried over. Everything looks fine. Okay. Everything's fine. I can leave that. Okay. Everything's good. So what this is our order of operations. So it'll do the holes first and then the outside. Okay. Everything looks good. The blue here is representing the path that the torch is going to take to cut everything. All right. So what we can do is post-process. Let's save that. Replacing the existing ones. Post-processor says that everything was good. We'll get out of there. Right. So the next thing we're going to do is we're going to take this drawing and import it into the StarLab, which is the table control. And now the code that this generated will tell this program where to send the torch. All right, and we'll do that next. All right. All right. So we're going to come down here and I'm going to open up the table, the StarLab command CNC that takes the code that we just generated, and this is what it tells the table to do. Okay, so first thing we're going to do, so I've already turned the machine on outside. I'll show you that. We're going to take it out of e-stop, so that just stops the machine. We're going to open up our file right there. We can zoom in a little bit. So this shows our part. It shows where the torch is right here. Okay, this is our 0, and then it shows our dimensions. So we're 25.04 by 20.04 overall. So it's taking into account that 0.04 is taking into account the width of the plasma beam coming off the plasma cutter. So that's how much is lost. Right, so everything looks fine. I'm going to go out to the table, take you out there, and we'll set it to where we need it on the material, and we'll try a cut. All right. All right, so we're out here in the shop. I just wanted to show you the plasma table, kind of what it looks like and how it operates. So what this is a 4x4 CNC plasma table. It's got a little bit of dust in the water, so this is a water bed. So it's got a few inches of water that keeps the smoke down and cools the metal if the metal's close to it. The metal sits on there. What you see back here is the gantry that runs back and forth, side to side and front to back. I'll show you that. Down below is the plasma cutter, similar to the one that we have at school, just maybe a little bit. It's kind of in between the one that Rodriguez has and that we have, kind of a medium size. This is the controller for the table. It's got all the drivers inside that are operating the motors up top. So the computer's talking to this. And it's got all kinds of sensors and stuff to sense what's going on. Over here I've got the levers so I can raise and lower the water, so I can put it back into a tank. So I got a 35-gallon tank in the back, and I can raise and lower it just with air pressure. So this controls the air. It'll actually raise up all the water, 35 gallons, into the top tank with about 1 to 2 pounds of air pressure. It actually pushes it up with very little air, kind of cool. It takes a few minutes, and then just gravity drains it back down. I can also, with this machine, hook up a router and do some routing. So I've done some wood routing and some plastic stuff. So kind of cool, versatile machine. So what I'm going to do is I'm going to load the metal up on here, and we'll try cutting, see what happens. All right, so I've got the piece of metal. Now this is just a piece of metal that we had at school. Then you can look at the back side, you can see all the practice lace and the designs everybody was doing. So what I did was I just kind of took off most of the primer and paint that was on the side. So hopefully it works all right. And what I'm going to do, since it has some paint on there, excuse me, I'm going to put a ground clamp on this. Typically it's grounded by the just the slats that are in there, but since it's got some paint on there, I just want to make sure that it's getting grounded. And actually what I've been doing is putting a little bit of metal on here to hold it down, just because it's so thin it wants to move around a little bit. So we'll just try to keep it down with some chunks of steel. So we've got it grounded. All right. Now what I'm going to do is I'm going to bring my gantry, so I can, just with the remote here, it's got a joystick and a couple of settings I can change. So what I want to do is I want to bring it down to where it's going to start. All right. And you can see the torch will go up and down. So I want to bring it close to the metal. I want to bring it kind of where I'm going to be. I want to keep it off the paint. Excuse me. So I want to make sure that it's going to clear everything. So we're doing a 20 by 24. So it looks like we're going to be good. There's some practice cuts on the other side you can see that I was doing last night. So hopefully we're good. I want to get some of the water off. The water doesn't affect it on the top. It's just when it's sensing the metal, you don't want to have any water up top, because otherwise it thinks the metal is a lot thicker than it is. All right. So what I'm going to do, let me take inside. Cleaned up my mess here. So I'm going to come in here real quick. And on the machine itself, so on here, I'm going to come over here and we're going to zero out our axis, X and Y axis. So that'll tell the machine that it's zeroed out right where we placed it. Okay, so that's where it's going to start, and then it'll do this pattern. All right, so we're ready to go. Wish me luck. So come back out. So with any luck, this will work. Okay, so all I'm going to do, push run, and hope. There's a hole, so it's doing the holes first. Now it's going to go around and do the perimeter. There you have it. The machine will continue to run to cool off. And you can see some of the smoke in here. Let me turn on my fan. So the water level was a little bit low, so we got a little bit excessive smoke. We'll have to fill it back up. So undo the clamp. Let's move the gantry out of the way. Get our metal out. So I'm just going to push it back. There's our panel. Got a little bit of water on it, but we got the holes made. All the corners are rounded. Pretty cool.